In today's lesson, it's topic 14. I'm sorry. Messing up straight away here. Topic 14, lesson 3, is about polygons. Now, when we talk about polygons, we talk about shapes that are closed figures. So think about open figure versus a closed figure. Okay. Our I can statement is that we will use essential attributes to define 2- and 3-dimensional geometric figures. So we will use attributes or features, characteristics, things that we can use to describe them, descriptions, to define 2D and 3D geometric figures. Okay. The first thing we need to understand is the definition of a polygon. I'm going to put this over here. Polygons. I'll put the definition here. Polygon is a closed plane figure, and by plane meaning it's on a plane, a shape that goes on in all directions in one flat area, like a surface. Okay. It's a closed plane figure made of line segments. Now today we're going to talk about 2-dimensional shapes only. Each line segment is a side. And then the point where two sides meet is a vertex. Point where two sides meet. Now you can have more than one. Vertices is plural. And the way I always remember it is here's your V and there's your point, and that's you're looking for points. So let's look at the different kinds of polygons that we already know names of. This shape is a triangle. A triangle has 1, 2, 3 sides, and it has 1, 2, 3 vertices. A quadrilateral is any shape that has 4 sides. 1, 2, 3, 4. Quad has 4 sides and 1, 2, 3, 4 vertices. A pentagon we normally think of as this shape of a house. But remember, that's if all the sides are the same length. They aren't always the same length, but it's still a pentagon. So a pentagon has 5 sides and 5 vertices. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 vertices. I'll pause. The next shape we're going to look at is a pentagon. Actually, I drew a pentagon, a hexagon. Let's do that. Okay, it's a closed shape with 1, 2, 3, 4, 5, 6 sides. Hexagon. And it has 6 vertices. And then finally, most of you know of an octagon, which looks like a stop sign. Now, if you want to, you can label these with numbers. So as you count, you can actually show the number. So this is an octagon. An octopus has 8 legs. If anything's octagonally shaped, it has 8 sides and 8 vertices. Now, we'll be working in class, but I wanted to show you what a non-polygon is. Okay? It does not have one of the definitions that make a polygon. So, for example, if I had a shape like this, it's not closed. So this is not closed. So it is not a polygon. Let's say we have another shape and it has a curved top. Even if it's closed, this curved shape makes it not a polygon, not a line segment. So it is not a polygon. Okay? And let's say you had a shape like this, where these cross over. Because these keep going in the same direction, and they're not line segments, we'd say not line segments. So it's not a polygon. We'll actually look at more of these shapes in class. One last thing I wanted to explain is that these shapes or figures that are drawn on the board are two-dimensional. They are 2D shapes. They can be the surface of a 3D shape, but if you just have the one picture with nothing else, then that is 2 dimensions. It's just one surface, one plane. It doesn't hit more than one plane, but it does, however, have length. So you can find the area of some shapes because it has length and it has width. Now, it takes advanced math to show the area of an octagon or a hexagon or a pentagon, but you can find the area of squares and rectangles and other shapes where you're able to look at the sides. You can also find the perimeter of these by going around and adding up the line segments. We have separate lessons for this, but I just wanted to remind you that the area of this is the length and the width. You can find the area of a polygon. You can also find the perimeter of a polygon. But you cannot find the volume of a polygon because it is not 3D. Okay, that concludes this lesson. Have a great day.